Okay, you guys, talking about angular velocity here with Mr. Hinders and his bicycle, how fast something is turning around, how fast something is turning. So we start off with Mr. Hinders riding his bike to work each day, so the wheel goes around 5 times every second. So there are 5 revolutions for each second, for 1 second. And it wants the answers in radians. So I'm going to just change this to radians. So I know that 1 revolution of a circle is 2 pi radians. So that's equal to, and see, we do dimensional analysis because these will cancel out. And then we get 5 times 2 pi is 10 pi radians for 1 second. Okay, and then we're going to use this information for question number 5, which says if the diameter of bicycle is 20 inches, how fast is Mr. Hinders riding in feet per second? So I already know we're going to have to change seconds to feet, right? Feet per second. And it tells me that the diameter is 20, but in order to figure out the distance it's going, I need to know the circumference. So the circumference is equal to pi times the diameter, or 2 pi r, but I always think of it this way, pi times the diameter. So the circumference for his wheel is 20 pi. Okay, and instead of 10 pi radians for 1 second, oh, why was I saying we need to change feet per second? What was I thinking of? Oh, we need to change his bicycle from inches to feet, but we'll do that in the middle of our dimensional analysis. So what we have is, we have 20 pi inches, and if we want to convert it, we're going to multiply it by, we want feet, right? So there's 12 inches in 1 foot. And inches goes on the denominator, so it can cancel in 1 foot. So our speed has changed from 20 pi inches, our circumference has changed from 20 pi inches to 20 over 12. What does that reduce down to? Both of them are divisible by 4. So 5 pi over 3 and feet. Okay, and that's just his circumference in feet, is 5 pi over 3. So we want how many feet per second is he going. So this is how far it goes, his bike goes when the wheel turns around 1 time. And the wheel turns around 5 times every second. So we have 5 revolutions for 1 second. We got this from the original question above, right? Times, he goes 5 pi over 3 feet each revolution. So how many feet per second is he traveling? He is traveling, if I do the multiplication here, 25 pi over 3 feet per second. And I will be doing another video with some extra questions about this. There'll be a question just like these two on the test. All right, what is next? Sketch a graph of the unit circle, then draw and label the following angles. Then state the sine, cosine, and tangent of each angle. So I wonder if I can insert a shape I would like to insert a circle here. Tools, view, I don't see it. Well, I'll just draw one as best as I can. So if I have a circle, sketch my graph here, pi over 4, right? If this is pi, this is half a pi, which is pi over 2. And this is half of a half. And half of half is a fourth, so this is pi over 4. Okay, then state the sine, cosine, and tangent of each angle. Well, you guys will be able to use your unit circle, so you should just be able to say, my point right here is the cosine comma sine, and this is 45, 45, 90, right? So it's a square root of 2 over 2, comma, square root of 2 over 2. This is the cosine, this is the sine, and the tangent is just 1, because the tangent is the opposite over the adjacent there, which is just the sine over the cosine. And when you put the square root of 2 over 2 over the square root of 2 over 2, you just get 1 whole. Okay, so the tangent is 1, but that should also be on your unit circle. Now, sketch a graph of the unit circle. And it's a negative angle, so what we're going to be doing is going clockwise here, going this way. Negative pi over 3. Pi over 3 is like 60 degrees, so we're going negative 60 degrees. Negative pi over 3. And the sine, cosine, and tangent for each angle, well, it's going to be the same exact thing as pi over 3 or 60 degrees in quadrant 1. Except this time my y is going to be negative. So I think 60 degrees means that my sine is going to be bigger than my cosine. So this will be the square root of 3 over 2. So that's the sine. That'll be the sine. And the cosine will be 1/2. Oh, except one of these is negative, it's the sine, so negative this. And the tangent is going to be, like I said, you should just be able to look on your unit circle to find this part of it. But the tangent is going to be the opposite over the adjacent, so negative root 3 over 2 divided by 1 over 2. Which just means negative root 3 over 2 times 2 over 1. My 2's cancel. And so my tangent should just be negative root 3. All right, what's next? I think we have time to do another one. Oh, 3 pi. Is that part of this? Okay, 3 pi. So if we're going to graph 3 pi, here's what that came out well, right? Okay, so I'm going around. There's 1 pi. 2 pi's, 3 pi. So 3 pi and regular pi are going to be the same thing. You just got to look at the quadrant. So right here, my x value is going to be -1. My y value is going to be 0. And my tangent is going to be 0 divided by -1, which is just 0. Now remember, you can have a 0 on the numerator and divide it by any number, you get 0. You cannot have a 0 on the denominator. So if that happens, it would be undefined. Okay, write an equation for the following graph in terms of, remind me later, stupid thing, in terms of sine. So sine, our sine curve, is our y value. It's the height of the circle. So at 0, it usually starts at 0. So here is where our sine curve normally starts at. And then it goes up to 1, right? And so here's the highest point it gets to would be, let's see, how many do you think this is? What's 1 revolution? Here. So 1, 2, 3, 4, 5, 6. So we just call that 6. And then 1, 2, 3. Oh no, let's call it 7. and then there, and then 1, 2, 3, 1, 2, no, let's call it 6, and that way this will be our half point. This will be pi. This will be, or this will be pi over 2. This will be pi. This will be 3 pi over 2. And then this will be 2 pi over here. So it looks like we've just taken the sine curve and we've literally shifted it up by 1, 2, 3, 4. So this, because if I just did the regular sine curve, it would look like this, right? So it looks like we've just taken the sine curve and we've shifted it up by 1, 2, 3, 4. So f of x equals sine of x plus 4. Okay, and you can do that in the calculator. If we went to y equals, I don't know why it's not working. And you can always kind of see what it looks like by typing in. This is what I should have done. First is go in here, type in sine of x. Okay, make sure your mode is radians, which it is. Do you see I'm circling it with the mouse right there? Then we can kind of do a zoom 6, but it's going to look a little bit funny. Maybe we can do zoom 6. That looks like that's what is on the paper. Okay, so that's the sine. And then if we move it up 4, let's see if that works. Oh, it's still thinking. And let's see if that works. If we have sine of x plus 4, and oh, it's going to be mad at me because I added an extra parenthesis, and graph that. Okay, that looks a bit right, except it does look like we stretched it up a little bit. So I think I'm going to have to add on a stretch, a vertical stretch. So if we go back here, on a normal sine curve, the amplitude, or from the top to this line, is 1. But here, it looks like from the top to here is 2. And I'm just looking at these little check marks over there. So let's see if we do that. We need to stretch it by 2 and see if it looks a little more like what we have here. So to stretch it by 2, we're going to put it in the very beginning. So I already added 4, so I'm going to do second insert here, 2. So I added an amplitude of 2. So I have 2 sine x plus 4. Let's see if that looks a little bit better. This is just the original sine function. Okay, and there's the new one. That looks about right. That looks better. So what I need to add onto here is that this is wrong. It's f of x is equal to 2 times sine of x plus 4. And we only do have, I guess we have a couple more. We'll have to do a whole other video.